So
Yes.
in 1966, I got a job in IIT where there
IIT
were
Delhi.
very good professors. I had the opportunity to
Mm.
work and interact with Professor M.S. Sudha. And he also had American training. He was a friend. Although he was
Mm.
not senior, he was a professor, but he was a
Mm.
friend, well-wisher, and everything. All the time accessible. Although he became the head later, I developed great friendship with him. And IIT Delhi had a very good optics program. And that was
Oh,
suggested by Professor D.S. Kothari. Professor
okay.
D.S. Kothari said that since this is an institute of technology, lens grinding, optical design, and things like that. So he had the visions. He said that IIT Delhi, because it's a technological institute, should go
Mm.
for that. So then two very nice things happened. So
Mm.
after 2 years of this thing, Professor Sodha was visiting Drexel University in USA, and he wrote to me
Mm.
there was no WhatsApp call or something like that. He wrote to me that Ajoy, fiber optics is coming up in a very big way. You
Mm.
start working on fiber optic, and
Mm.
I have some problems in my mind. Would you like to
Mm.
do that? Then I wrote
Mm.
him that my work on neutron transport theory is going on well, and by that time IC Goel had joined, so we formed a small group. He
Yeah.
said that you continue with that work. It is after all theory. Some of the things that you do there can apply here. He was a
Mm.
very helpful visionary. He said you join.
Mm.
So I said, all right. I could not say no to him. You see, although we were almost like senior, friends. But
Mm.
if Professor Soda or Professor L.S. Kothari or Professor D.S. Kothari says something, we never
Yeah.
could say no. You see, we belong to that generation.
That
My father
generation.
would say something, and I cannot say no to him.
Mm.
Now, of course, things are different. But during our times, to any elder, even my chacha, uncle, I cannot say no to him. If he says something, he has to. So
Yeah.
Professor Soda has asked me to do that. He was born in 30, so 7, 8 years older than me. So
Mm.
I say I cannot say no to him.
Mm.
And then he said that you work in fiber optics, you start your work. He suggested me a problem,
Oh,
and he
okay.
outlined me that is
Mm.
तरह से you do it like this. So he was also a very great physicist. So we started work. That's how I got into optics.
Okay.
When I joined,
Mm.
Professor Lokanathan was teaching quantum mechanics at IIT
Oh.
Delhi.
Mm.
And since I was very fond of quantum mechanics, and he
Mm.
had training from Columbia, Professor Lokanathan,
Mm.
and he worked with Serber. So I started, in addition to my teaching duties, I
Mm.
started attending his class because he worked on applications of quantum mechanics, and he was a remarkably good human being. He is 95. He's about
Mm.
10 years older than me, and
Mm.
he lives in Bangalore. And
Mm.
remarkable, very good human being. And I would talk to him and learn from him and start discussing. So I started attending his classes and would
Mhm.
discuss and argue about the solutions that he would put forward. And then suddenly he got a professorship at Jodhpur, and,
Okay.
uh, and he was leaving. And this was around 67 or 68. And
Mm.
then Professor Soda was the head of the department. And he said, since you have been attending his work, you take over the quantum mechanics.
Okay.
And and I of course loved that subject,
Mm.
and so I of course said yes. And then what
Mm.
happened was that
Mm.
because of my background at Cornell, I had a large number of problems. I had discussions with Professor Lokanathan and things like that.
Mm.
And
Mm.
so uh, I prepared, I would prepare a large number of questions and answers. And
Mm.
Professor Lokanathan also used to do that. And
Mm.
he left for Jodhpur. And then Professor Bawulal Saraf, I don't know whether you have heard his name or not. He used to be in Jaipur. So he asked Lokanathan to join Jaipur. He came over, and
Mm.
then we started talking, Professor Lokanathan and myself.
Mm.
Whenever Professor Lokanathan will come to Delhi, on
Mm.
writing a book just on problems and solutions.
Okay.
And in fact, our contract with Macmillan was, the title of the book was, I still have that, Problems and Solutions in Quantum Mechanics. So we prepared a large, over the course of 2-3 years. So the first edition came out in 1975. So just now, IAPT, Indian Association for Physics Teachers,
Physics teachers.
organized an interview in which it's very nice of them that they said that 50 years of quantum mechanics book. Now it is in the sixth edition
Yeah.
and expanded. But it started with problems and solutions. Then every year I would at least teach one course on quantum mechanics, either quantum mechanics 1 or quantum mechanics 2, and one course on optics or applied optics and things like that. So I was very passionate about teaching. I took it very seriously. I dedicated myself and I enjoyed. I still enjoy. I still enjoy teaching physics and I am 85. I was just telling my wife the other day that I still want to teach quantum mechanics, the basic quantum mechanics, and the electron. When you explain the double slit experiment, electron passes through both the holes simultaneously. I can make them understand that it is neither a wave
Yeah.
nor a particle. So the
Yeah.
question is, some books write, sometimes it's a wave, sometimes it's a particle. That is a wrong answer. Feynman very beautifully says that it is neither a wave nor a particle. It is neither a wave nor a particle. Then what is it? It is described by the wave function psi, which is the solution of the Schrodinger equation, which cannot be derived.
Yeah.
Which cannot be derived. So I think I can explain basic quantum mechanics, basic concepts in quantum mechanics.
This is the edition I have.
Oh my!
Fifth. It's a fifth edition. I
This
remember
is the
when I was
double
in
slit interference pattern.
masters.
This is the
Yeah.
double slit interference pattern. This is
Yeah. Yeah.
sort
It
of
had some article from
Weissbrot.
earlier. Right. So that's already there.
So eventually it expanded, and Professor Lokanathan, I mean, he had become aged also. Then he lost his wife. So I think the most later editions I tried to do it, and of course consult him and things like that. So, but I enjoyed teaching, and I enjoyed writing that book,
Hmm.
revising that book. Even I have now still some. You see, when you teach very well
Hmm.
and teach with dedication,
Yeah.
then, and this is with anything, then you will get new. Even if you are a good singer and if you sing with passion, then new tunes will come up, new ways of it making things understand. And
Sometimes my own experience, sir, is that sometimes things which are not clear even prior to the lecture, during the lecture while you're teaching, things become clear. Oh, this is what things come to
this is
mind,
what, that is true. That is what Professor D.S. Kothari mentioned. That if you want to learn a subject in depth, you have to teach it. And this happened with my optics. That is how I got very deeply involved. And I have now a very simple derivation of E is equal to mc square. I collaborated with a
Okay.
professor in America, and you have a pi meson at rest inside a train. I am
Okay.
inside the train, and
Hmm.
that disintegrates to two photons.
Hmm.
And since the pi meson is at rest, the two photons must have equal and opposite momentum, and so
Opposite
therefore
moment.
equal and equal frequencies. So h nu naught and h nu naught. So
Hmm.
therefore matter transforming to energy. So the energy of the pi meson is
Hmm.
2 h nu naught. 2
Hmm.
h nu naught.
Yeah.
Then in your frame of reference, let us suppose the train is moving, the source, the pi meson itself is moving with a velocity, say
Hmm.
10 kilometers per second or something like that. So you put two observers, one here and one there, and
Hmm.
then one observes higher frequency,
Hmm.
Doppler shifted, the other
Okay.
observes smaller frequency. And
Hmm.
if you add them together,
Okay.
h nu 1 plus h nu 2, very
Hmm.
simple algebra,
Hmm. Hmm. Hmm.
you will get the total energy slightly more. Gamma
Oh.
times 2h nu naught. Gamma
Hmm.
times 2h nu naught. And gamma
Hmm.
is the Lorentz factor, which is always greater than
Yeah.
1. So I
Yeah.
will measure certain energy, you will measure a slightly higher energy. And that
Hmm.
is because the difference will be the kinetic energy,
Hmm.
relativistic kinetic energy.
Can
And
become,
then
yeah.
you make a Taylor series expansion. And
Mm-hmm.
for non-relativistic limit,
Mm-hmm.
you evaluate that, equate it to half mu square, half m0 u square,
Mm-hmm.
and you will get the equation. I will send you the derivation. You will get the equation E is equal to mc square. This is a
Oh,
beautiful derivation. I'm very
yeah.
excited about it, and I am trying to project that this derivation should be in all schools, not
Oh,
just in India,
yeah,
but
yeah.
globally. So I'm very excited about it. So my lectures are now, I've come down to school level.
It's very important, sir, because while problem solving is one very important skill set students should acquire, having that deeper insight, what they
Ah,
are solving, really what that mathematics means, right? That's
ah.
very important. So, it,
So what I would like to add is that in IIT,
hmm,
we were all very fortunate to get
hmm,
very good quality students. That,
hmm,
you see, at MSc or undergraduate level, if you are
hmm,
teaching optics or if you are teaching quantum mechanics or any other subject, you
hmm,
have to be very clear about
the
your
concepts and
own concepts, because the
hmm,
students will catch you. Students
yeah,
will catch. So therefore, you have to prepare very well so that you
hmm,
don't get into an embarrassing situation. And my
hmm,
PhD students, I was really very fortunate to get outstanding PhD students who did PhD with me and my friend. We had formed a small group. So that way, I was very fortunate, and that's how the work got recognized. The work became good, and they also enjoyed, I also enjoyed, and I had a very friendly association with it.
so when did you started thinking about writing books on optics as well, right? Quantum mechanics now I know.
Same thing. That when
Oh,
I started teaching optics, when 3 years later, the first edition came out in 1977. So I hope
hmm,
I live for 2 more years to see the 50 years, 50 years of optics. So,
yeah.
so at that time, lasers came in, and you can do very nice experiments, diffraction, interference experiments on these things. And then Feynman lectures came up. And you see, Feynman lectures came up, and the double slit experiment that he says, that's what Feynman mentions, that
Hmm,
all concepts in quantum mechanics can be understood if you understand the double slit experiment. So
yeah.
it's also optics. So these things I introduced, I would teach, and then I thought that I must write them up. And and the lasers, experiments with lasers and things like that. So I would like to mention one more thing.
Hmm,
I left Cornell in 1963 June,
hmm,
and I was at Brookhaven for 1.5 years.
hmm,
In 1964, Richard Feynman gave 6 messenger lectures at
yeah.
Cornell University. Beautiful,
Hmm,
and they were, of course, partly based on the book, and by that time, books had come out. So my greatest regret was, this is what I tell the younger generation. My greatest regret was that I could not hear the Feynman.
fine.
I could
Itself.
not hear Feynman. Being a student at Cornell, I could not hear Feynman. Now we are so fortunate that we have YouTube and we can hear the Feynman. I must have heard the first and the sixth lecture. The first lecture on gravitation and the sixth lecture
Yeah.
on probability and uncertainty about n number of times. And
Hmm,
each time, the way he says, you see, the greatest thing about Feynman and his books are that
hmm,
there is not a single error that you can. That's a very big thing, and I also, in my own little way, I have tried my best that not to make one single erroneous statement in the
hmm,
book, not wrong statement. In others, if you are not understanding it, even I do not understand some parts of quantum mechanics and some parts of
hmm.
optics. So I rather avoid that, but rather than to make a wrong statement, I still feel one-to-one interaction and things like that, and reading from a good book is always a pleasure. But
Yeah.
people say that you can read equally well from your mobile phone or something like that. I just cannot imagine how I can read from a mobile phone and things like that.
How did your early experience as a teacher influence your writing style or the kind of books you wanted to create? So how did that like writing style got affected?
You see, I have taught quantum mechanics and optics many times. So
Hmm,
each time a new way of introducing this subject will come up, new way of understanding wave particle duality, quantum mechanics experiments, and things like that. That is how, and sometime I will get some other book and find a very beautiful problem there, and I would like to teach that in my own way. The
mm,
applications in spectroscopy, application in nuclear physics, and things like that. So then you feel like that maybe I should have done it this way. I have a simple way of, for example, apart from understanding the tools of two-pole indifference experiment, also getting to Fourier transform theory. You see, in quantum
mm.
mechanics, you have to use the Fourier transform theory.
Great
So
answer.
I use that to first derive the Dirac delta function, and
Yeah, it,
the Dirac
this
delta function,
starts with
and
direct delta
you
function
get
and
a
then
style. Yes, then you have the integral representation of the Dirac delta function, and from
mm,
that you derive the Fourier transform. It comes out good. In fact, I gave that NPTEL recorded lecture, and some foreigners wrote that that's one of the most beautiful derivation that he had. That is my own. These are not own. There is no discovery there. There is no discovery there. But it's a new way of
yeah.
getting to Fourier transform.
Sir, I call this as a pedagogical discovery in a sense that it's
Yes.
not a discovery of
Yes.
a new concept, but
Yes.
it's a way of teaching something which is more complex or difficult, and you kind of find a nice way to navigate. So it's a
That's
pedagogical.
that. That is true even for the new derivation that we have for E is equal to MC square. I would
Yes. Yeah.
as you very correctly say, that it is a pedagogical contribution, and therefore the
Yeah.
most appropriate journal was American Journal. But it gave me. But now I personally I've tried it out with some of the people at class 12 level, and they have
Mm.
understood it. They have
Oh.
understood the derivation of E is equal to MC square. That energy can be transformed to mass, and
Mm.
mass can be transformed. And that very famous sentence of Einstein that he wrote to his friend Conrad Habit, that light carries mass with it. That is what he said in 1905. That when
Mm.
he derived the equation, published the paper, he said that light carries mass with it. And he said, if I remember correctly, the idea is seductive and amusing. But I think the Lord maybe, he did not himself believe. He said that maybe I am wrong and things like that.
Mm.
So now I have a, now the derivation that Einstein gave, that was of course correct, but it is so difficult to understand. Now I have a
Mm.
derivation which is very easy to understand. So it's in my opinion, it's a big contribution.
Yes, yes.
It's a pedagogical, as you correctly say, it's a pedagogical
Mm.
contribution.
In your view, what kind of skills or habits indicate that a student is research ready?
In my opinion, the thesis advisor plays the best role. That is in America, they say that a PhD degree allows you to think independent. So, how much does
Mm.
the PhD supervisor guides you? You see, too much of guidance is also not
Mm.
good, and he allows
Yeah.
you to develop skills for yourself. So that the role that is played
Mm.
by the PhD supervisor is most important. Is most important, and he tells you to think and solve a problem. There is a very famous quote that a student
Mm.
once got PhD admission with Professor Dirac. So he went and
PM.
the
Yes, sir.
first day he says that you study quantum mechanics. It's the early part of quantum mechanics. And then in 6 months, he says that suggest me a problem. He says, if I know of
Mm.
a problem, I'll solve it myself. If I have a problem, I'll solve it myself. But you find a problem and you find the solution. So that is another limit of independence that the and during those days there is to be always a single author paper. DAX all papers are single author, and he allowed all his
Yeah,
students
yeah.
to publish, all his PhD students to publish single author paper.
Okay, single.
He said that we will talk, we will discuss.
Mm.
You ask me questions. If I can answer, I will answer. But you have to think. So this is another limit. But we usually don't do that. We give a broad problem and then allow students to think and come up with that. So So a major portion of the doctoral program is for a person to think or experiment independently, and that is
Mm.
the thing. And if you say that these are the calculations that you have to do, and then he does that, and you produce a paper, and that is the thesis, that is unfortunately what is happening in some cases. But that is not the purpose of PhD.
Mm.
PhD is to independently think.
Yeah. Sir, I have some short Q&A questions.
Okay, follow it.
Quite interesting. You can, whatever comes to your mind first, you can think and answer. So,
Don't ask
let's say
difficult
if
questions.
time travel were possible.
Ah,
No, sir, it's time travel were possible. Assume that. Which scientist or physicist would you most like to meet and have a conversation with?
Feynman. 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 Of course.
And what would be your conversation with Feynman? What would you
Oh,
discuss
I
with
would
him?
like to have a one-to-one conversation on basic concepts in quantum mechanics. How does electron, which has a definite mass and a definite charge, pass through both holes simultaneously? That is the question that I will ask him, and that I ask everyone else also. How do you visualize? He himself said that the electron passes through both the holes simultaneously. But if you make a measurement, then it will either be this hole or that hole. So it will collapse. I have been teaching this. Do I understand it fully? I do not.
Hmm.
And that's what the famous statement of Feynman is, that no one understands quantum mechanics. You see, another problem that comes in is Max Planck had introduced the quantum of energy. You see, the walls of the cavity have discrete energy. That was
Hmm.
1899 or
Hmm.
1900. Then Einstein introduced in
Yeah.
1905 that light quantum, that light travels in
Yeah.
packets
Yeah.
of energy.
Hmm.
Then Niels Bohr in 1913
Hmm.
put forward his famous theory of the hydrogen atom, and he says that when when a when the hydrogen atom goes from the 2p state to the 1s state, it makes a transition.
Hmm.
It creates a light quantum. But he does not believe. He said that in 1913 he did not believe in the light quantum. So what
Hmm.
emits between the 2p and the
Hmm.
1s state is a packet of energy, but he still does not believe in
Hmm.
light. So if I meet Niels Bohr,
Hmm.
so this is the question that I would like to ask.
Were there any books that sparked your early interest in physics? Any books that you read and you found very fascinating?
Oh, so D.S. Kothari taught us from Dirac's book. That was a
Okay.
very beautiful book. Dirac's book on quantum mechanics. That was, and the good news was that D.S. Kothari followed almost verbatim from that book. That was
Hmm.
one of the most fascinating books that I have ever come across. The
Hmm.
book that we used for electromagnetic theory, I still remember, was
Hmm.
Stratton. That we found very, very difficult, very difficult. And we would spend hours to understand. Professor Surya Prakash used to teach us. And then classical mechanics, he followed, Professor Olak followed Goldstein's book. But the book that we loved most was Dirac's book. So
Hmm.
because of two things. First of all, it is a classic book of quantum mechanics. Secondly, Professor D.S. Kothari followed that book almost line by line.
Hmm. What qualities do you believe are essential in a good researcher?
You have to just keep thinking, keep focusing on the ideas, and expecting no returns. Just painstakingly working on the problem, and sometimes we reach a dead end, and read related papers, see how others have
Hmm.
approached the solution, and not just give up. And talk to your friends, your teachers, and discuss. That is the best way to
Hmm.
get to new ideas. Like, as you said, in pedagogy, how do you generate new ways of teaching a subject? By
Yeah.
teaching students and things like that. So talk, discuss, and by discussing, sometimes new ideas will come.
When you are not thinking about physics, how would you how to unwind or relax? Like, what are your ways of relaxing?
There are quite a few things. In the good old days, we would watch movies. My
mm,
wife and I, sometimes with children, we would go to the cinema hall, and that used to be a very good way. I mean, I still remember there were some movies, I rather not name them, I've seen two, three times or something like that. But now, with television and this thing, going to a movie theater has become very rare. And we have become much older. What my wife and I feel listening to Rabindra Sangeet, what Rabindranath Tagore composed
mm,
100 years back is something remarkable. And the words that the songs, the script that he created, the thoughts that he conveyed are just profound. He says, for example, in one song, there are so many, each song, each verse has a story, something to learn. He
mm,
says, "He more rokha karo, inahe more prarthana." And I have misfortune coming to me. Oh my God,
mm,
help me. Take me out of
mm,
that. That is not my prayer. That is not my prayer. You
mm,
give me the strength to bear it. And think like it's a very simple two-line thing, and it conveys so much because we face difficulties every time,
mm,
and in every this thing. He says that when we have difficult times, we should not get afraid. And he had himself a very, very sad life. He lost his wife, he lost his children, and sister, and so on. So he once told his friend that Mrituke bhoy paina, that I am never scared of death and things like that.
mm,
But the compassion that he had for everyone, and the compassion that he shows in and someday, when you come to Delhi, I will tell you some some stories that he has written, and so
mm.
heart touching that that
Oh,
that
okay.
in the end, a person says that someone has committed a sin, the girl has committed a sin, some wrongdoing, and
Mm,
her friend is unable, or her husband is unable to forgive her. And then in the final hours of his life, he says to God that I could not forgive. You will probably forgive her, but
mm,
I could not forgive him. That is my greatest fault. He admits that I could not forgive. So forgiveness is things like that, things, concepts like that.
mm,
Each story has a
mm.
tremendous. So and
Message.
fortunately now with television, you have programs on Rabindra Sangeet, and you have YouTube also. So that my wife also enjoys that very much. So we watch it
Mm.
together. So that is a very big relaxing thing.
Coming back to physics, like, is there any unsolved problem or question that is still unanswered that you would like to see getting answered or
Oh
resolved
yes,
during your
I'm
time?
thinking of doing his calculation. I'll tell you later. But there are several such things. Yes, of course there are several things. You see, what I feel is that I miss IIT. Let me tell you, I am in America now. They have no age of retirement.
Hmm.
But in Indian institutes and universities, things are not good in the sense that at 65, the person is still very active. And not only that, there is no provision. They will make sure that you leave. There will be no room for you. There's nothing and things like that. And this is not only in Delhi, but everywhere, everywhere. This has to change. This has to change. And uh, so I wish I had young students to interact, share my
Yeah.
ideas, and whatever possible. But that provision, the Indian
Hmm.
institutions do not have. We are little closed-minded in that. We are
Hmm.
closed-minded in that. When I tried my best to have some visitors coming and spending 2, 3 months there or something like that, so
Hmm.
that was resisted on. And so a good cafeteria and things like that. And all my
Hmm.
life I have fought for a good cafeteria in IIT Delhi, and not there. Where students and faculty, because that I remember, which is missing
Hmm.
in Delhi University, that students and faculty can sit together and have
Together with.
discussions not only on physics but also employment opportunities, as you correctly say, and things like that. So that that thing is not there. And even at this age, I feel that I wish I had a forum where I can discuss things as I am discussing with you today about my thoughts and then get their viewpoints over a cup of coffee or something like that. That once you are out,
Absolutely.
you that is what C.R. Rao said, that you retire. See, who got a very big prize in the United States as statistician, and he said that
Mm,
the day I retired, uh, that's it. The,
mm,
the next head of the department said that you just leave, and then he went to USA and he did very good research work. So what a great talent that India
mm,
lost. And
mm.
he worked till 100 and he died at the age of 102. He got a president's medal for their work. So we do not know how to respect it.
Our faculties and brilliant.
We do not know. We still have not created a structure where today hierarchy is still very much there. And we do not have that. It's very unfortunate. It's very unfortunate. So I still feel that, and even in institutes like IITs, which are not short of money and things like that, there is too much of. I rather not say this on a public forum.
Professor Ghatak, thank you so much for this
Like
generous
that.
conversation. It's been truly enlightening to hear about your journey from your days as a student to becoming of course, a guiding force in the in
And
optics,
the only
especially.
thing that I can tell you at the end is that I still enjoy reading a good book on physics, not only other areas, but physics. I really enjoy. And when a difficult things becomes clear to me, and so that I can explain it in a simpler language, that makes me very, very happy. And that I'm still trying, still trying. So it has been my pleasure to talk to you, Mehul, and